Dr. N. Maheswari, Assistant Professor of Physics, Amet University, Chennai. Today we are going to see about piezoelectric oscillator. In this topic, how can we produce ultrasonic waves based on this oscillator? So, this topic only we have to see in today. So, today we are going to see about piezoelectric oscillator. So, based on the oscillator circuit, how can be produced ultrasonic waves? So, this is the important one for the today's scenario. So, before going to this topic, we know what is the basic principle about this oscillator. So, what is the basic principle means this oscillator work based on inverse piezoelectric effect. I hope you guys are well known about what is piezoelectric effect and inverse piezoelectric effect. So, what is meant by piezoelectric effect means so quartz is the best example of this piezoelectric crystal. This crystal is produce the ultrasonic waves. So, in this crystal it is a hexagonal shape. We are dividing this crystal into 3 axes x, y, z. You guys are already well known about this x and y z axis. This x axis is always electrical axis. The y axis is mechanical axis. This is z axis is optical axis. The ultrasonic waves produced only at the z axis, optical axis. So, what is meant by the piezoelectric effect means we are applying some potential difference on the x axis, the mechanical stress produced on the y axis, that is called as piezoelectric, that is called as inverse piezoelectric effect. Piezoelectric effect means is quite opposite to the inverse piezoelectric effect. We are applying some mechanical stress on the y axis, the potential difference produced at the electrical axis. So, this piezoelectric oscillator working based on the inverse piezoelectric effect. Inverse piezoelectric effect means we are applying some potential difference on the electrical axis, the mechanical vibration or stress produced on the y axis. So, the optical axis produce the ultrasonic waves. This is the basic principle of this piezoelectric oscillator. The quartz crystal is named as a piezoelectric crystal. This crystal is used to produce the ultrasonic waves. There are 2 types in this crystal, X-cut crystal and Y-cut crystal. What is meant by that X-cut crystal and Y-cut crystal means we are cutting this quartz crystal perpendicular to the x-axis, that is called as X-cut crystal. This X-cut crystal produces longitudinal waves, longitudinal ultrasonic waves. This Y-cut crystal means we are cutting the quartz crystal perpendicular to the y-axis. It produces transverse waves of ultrasonic waves. So we saw this basic principle and what are the types of this quartz crystal using in the piezoelectric oscillator. So, X-cut crystal means produce a longitudinal type of ultrasonic waves, Y-cut crystal means producing the transverse wave of ultrasonic waves. The next one, based on the principle, we are seeing about piezoelectric oscillator. Construction, working, resonance condition, then advantages. So, these are the topics we have to see in the piezoelectric oscillator. So, what is the construction of this piezoelectric oscillator means we are connecting one transistor, NPN transistor. This emitter terminal is going to ground and this base terminal is connected with one turn circuit. This capacitor is a variable capacitor. This induction coil is noted as L1. Another induction coil is connected here, that is noted at L2. This is connected with collector of the transistor, and these two end of this tank circuit and also another end of the L2 coil connected with the quartz crystal. Quartz crystal means connected at the A and B terminal. Inside this terminal only we have to fix the quartz crystal. And also this is the type of transformer. This is the primary coil, and the secondary coil, the induction coils are connected with the high tension battery. So this is the arrangement this is the construction for piezoelectric oscillator. So in this oscillator we have to use one transistor, and transistor is connected with one tank circuit. Tank circuit means induction coil parallelly connected with the capacitor. This tank circuit is again called it as oscillator circuit. It produces a frequency of this oscillator. Another induction coil connected with the collector of the transistor, and also it connected with these two ends are connected with the parallel plates A and B. Inside this parallel plates we have to fix the quartz crystal. And the secondary transformer coil noted as L3, this connected with the high tension battery. This is the construction of this piezoelectric oscillator. Then we have to see how it works and how can we produce the ultrasonic waves from this oscillator. So what is the what is the condition produce the ultrasonic waves means is the resonance condition. In the case of working, initially we have to switch the battery, high tension battery, the induction, the current produced in the circuit, okay, the current produced in the circuit, the transistor circuit. So due to the mutual inductance of these coils L1, L2, L3, this current is transferred to the another coil L3. So we have to see the construction of piezoelectric oscillator. In this oscillator circuit, we have to connect one NPN transistor. The emitter terminal is grounded. The base terminal is connected with one turn circuit. This turn circuit is called it as oscillator circuit of this circuit. This tank circuit means one inductance coil connected with one variable capacitor. That inductance coil is named as L1. Another inductance coil connected with the collector terminal. The two ends means the one end of the tank circuit and another end of the induction coil connected with one high tension battery, and this setup is known as transformer. This L3 coil, this induction coil is named as L3. This L3 coil is connected with two parallel plates A and B. So inside this parallel plates we have to fix the quartz crystal. This quartz crystal is the reason to producing the ultrasonic waves. So this is a construction. In this oscillator, one transformer and one transistor and one quartz crystal is connected. And the main thing of this oscillator circuit is this tank circuit. This tank circuit is the only reason to produce the frequency. What is the frequency of this oscillator of this circuit means 1 by 2 pi square root of LC. L is the inductance, C is the capacitance. In this case we have to use the variable type capacitor. Variable type means we can adjust the value of this capacitor. So this is the construction of this oscillator. Then working means initially we switch on the high tension battery, the current is produced in the transistor. Okay. So current produced in the transistor we have to use in the transformer primary circuit L1 and L2 coil. This coil transform the current into L3 coil by transformer action, and also the potential difference. Potential difference means the opposite charges are accumulated at the two ends of the plates. Okay, that time the crystal vibrates. So this is the case same to your inverse piezoelectric effect. We have to apply potential difference on the x-axis, mechanical vibration produced at the y-axis. So the potential difference produced at the two end of the plates, the mechanical vibration occur on the crystal. So crystal vibration started here. At that time, what is the frequency of this oscillator circuit means F is equal to 1 by square root of LC. L is the inductance, C is the capacitance. Then we have to adjust the value of the capacitor. Okay. So what did we do? We were adjusting the value of the capacitor, the frequency also change. What is the resonance condition means? The frequency change according to the variable capacitor value, at which time the oscillator frequency F is equal to the natural frequency of the crystal vibration. That time only the resonance occur. Again I repeat it as, what is resonance condition means? We have to adjust the variable capacitor in this circuit producing the frequency of this oscillator circuit, at which time the oscillator frequency match with the natural frequency of the crystal vibration, this quartz crystal. That time only the resonance occur. That time only at the end of the two plates of the crystal the ultrasonic waves will be produced. So this is the resonance condition and this is the condition for producing the ultrasonic waves. Okay. So again may repeat as, the resonance condition means at which time the frequency of the oscillator crystal coincide with the or equal to the natural frequency of the crystal vibration. That time only the ultrasonic waves produced at the end of the crystals. Okay. So what is the frequency of this oscillator circuit? 1 by 2 pi square root of LC, which is equal to, what is the frequency of this quartz crystal? P by 2L into E by rho. This L is the length of the crystal, E is the Young's modulus of the crystal, rho is the density of the crystal. Then P is the number of modes. Number of mode means the overtones, first overtone, second overtone. So at which time this frequency is equal to crystal vibration, frequency of the natural frequency of the crystal vibration. That time only ultrasonic waves produced by the crystal. So this is the resonance condition. And what is the advantage means? By using this oscillator we can be produced at maximum of 500 megahertz frequency of ultrasonic waves. Okay. What is the main disadvantage of using this crystal means? It's quite difficult, the cutting of the crystal and cost of the crystal. Already we saw what is the X cut and Y cut of the crystal. So the cutting is quite difficult in the quartz crystal and also this cost is very high. This is the main disadvantage, and the main advantages means maximum of 500 megahertz of ultrasonic waves is produced by this oscillator, and it is not a temperature dependent. Okay, at any temperature we have to produce the ultrasonic waves. Today we are going to see about piezoelectric oscillator. So based on the oscillator, how can we produce ultrasonic waves? This is the main learning objective of this session. Okay, so what is this piezoelectric oscillator means? It used to produce ultrasonic waves based on the principle of inverse piezoelectric effect. Okay. So I hope you guys are already well known about what is piezoelectric effect and also what is inverse piezoelectric effect. So what is mean by that piezoelectric effect means? Every crystal consists of 3 axes. Okay, that is called as X, Y and Z. So in this piezoelectric oscillator we have to use quartz crystal. It call it as piezoelectric crystal. Okay, this crystal consisting of 3 axes X, Y and Z. In this X, Y, Z axis, this X axis always call it as electrical axis and this Y axis always call it as mechanical axis and Z axis call it as optical axis. Okay. What is mean by piezoelectric effect means? We are applying some mechanical stress on the Y axis, the potential difference produced at the X axis. This principle is called as piezoelectric effect. Okay. So what is meant by inverse piezoelectric effect means? It's quite opposite to piezoelectric effect. We are applying potential difference at the X axis. So the mechanical vibration or mechanical states produced at the y-axis. This is the principle of inverse piezoelectric effect. Okay. So piezoelectric oscillator works based on the inverse piezoelectric effect. So we are applying some potential difference on the x-axis, mechanical states produced on the y-axis. That time the z-axis produced the ultrasonic waves. This is called as optical axis. In this axis only we have to obtain the ultrasonic waves. So this is the basic principle. Based on the principle only this piezoelectric oscillator works. Okay. This quartz crystal is called as piezoelectric crystal. This crystal is having the hexagonal shape, then A and B ends, this having the axis x, y and z. Okay. So this quartz crystal, in this quartz crystal we have to produce two modes of ultrasonic waves. One is called it as longitudinal wave, another one is transverse waves. So how can we produce longitudinal ultrasonic waves and how can we produce the transverse ultrasonic waves? So these two modes based on the cutting of the quartz crystal. Cutting of the quartz crystal means there are two cases, X cut and Y cut. Okay. What is mean by this X cut means we are cutting the quartz crystal perpendicular to the X axis. It called it as X cut crystal. Okay. This X cut crystal is used to produce the longitudinal ultrasonic waves. What is mean by this white cut crystal means we are cutting the quartz crystal perpendicular to the y axis. That time only this quartz crystal produces a transverse waves. Okay. I hope you guys are known what is mean by the transverse waves and longitudinal waves. So we are using the quartz crystal based on their cutting X cut and Y cut. We have to produce two modes of ultrasonic waves. One is longitudinal modes of ultrasonic waves and transverse mode of ultrasonic waves. So this is the basic principle before we are going to see about this piezoelectric oscillator. So again I am repeat it as this piezoelectric oscillator mainly focus on the inverse piezoelectric effect. We are giving some potential difference on the x-axis, the mechanical states produced at the y-axis, that time only the optical axis producing the ultrasonic waves. Okay. So the quartz crystal is the main thing to producing the ultrasonic waves in the case of piezoelectric oscillator. Okay. So this is the basic principle. Then what is the construction of this piezoelectric oscillator and what is the working condition of this piezoelectric oscillator and which time the resonance occur and what is the advantage of this piezoelectric oscillator. So these are the topics we have to see in the next session. So in this case of piezo oscillator working, what is the construction of this piezoelectric oscillator means we are using three main components. One is transistor, another one is transformer, next one is this quartz crystal. So these are the main things used in the construction of piezoelectric oscillator. Okay. Then in this case of construction we are connecting one NPN transistor. This arrow mark indicates this is NPN transistor. Okay. Always this emitter terminal is connected to ground and also this base terminal is connected with one tank circuit. Tank circuit means one inductance coil parallelly connected with capacitor. Okay. In this case we have to use one variable capacitor. This arrow mark indicates it is a variable. Variable means we can adjust the value of this capacitor. Okay. So what is the use of this tank circuit means? This is call it as oscillator circuit. It produces the frequency of this oscillator. oscillator circuit. So what is the frequency? F is equal to 1 by 2 pi square root of LC. L is the inductance, C is the capacitance. Okay. So used on this tank circuit, we have to obtain the frequency of this oscillator circuit. F is equal to 1 by 2 pi square root of LC. In this case, we have to use this variable capacitor, then only we have to adjust the value of this capacitor. So we have to get different value of this frequency of the oscillator circuit. Okay. This tank circuit is connected, and also another inductance coil connected with the collector of this transistor. The two ends, this is called it as L1, this is called it as L2. The two ends means the one end of tank circuit and another end of this inductance coil L2 connected with one high tension battery, positive and negative terminal. Okay, this is one set of this oscillator construction. So in this construction, we have to use one NPN transistor. The base terminal of this transistor connected with one tank circuit. The tank circuit consists of one inductance coil L1 and a variable capacitor C1. Okay, the ends of the tank circuit connected with the negative terminal of the battery, and another L2 coil connected with the collector of the transistor. The another end of the L2 coil connected with the positive terminal of the battery. Okay, this is one side construction. Then we already mentioned the transformer is used in the oscillator circuit. This is primary circuit. The secondary circuit is another inductance coil, name it as L3. Okay, connected with two parallel plates. Name it as A and B. Okay, so inside this parallel plate only we have to fix that quartz crystal. Okay, so this is the axis of the quartz crystal. We have to apply some potential difference of this axis. We have to produce the ultrasonic waves by this quartz crystal at the two ends. Okay, so this is the construction of this piezoelectric oscillator. In this oscillator, the inductance coils perform very neat manner. The L2 and inductance coil transform the current from this primary circuit to secondary circuit. Then only the potential difference produced at the two ends of the plates. Okay, so this is the construction. The next one is how the oscillator will works. Okay, initially we switch on the battery at the positive negative. It have some positive and negative terminal. Initially we switch on the battery. Okay, so what it occurs on the oscillator circuit? We switch on the battery, the transistor current produced in the transistor. Okay, the transistor used to produce current in the oscillator circuit. Then using this L1 and L2 coil or primary circuit of this transformer, the current is transformed to the L3 coil. So initially we are switch on the battery, the current produced in the circuit by using this transistor. This using of this L1 and L2 coil, the current is transformed to another coil L3, secondary circuit of the transformer. Then this L3 coil producing some potential difference across these plates. That means some positive and negative, this is called it as A and B. So positive and negative charges are accumulate at the two ends of the plates. Okay, so initially we switch on, current is produced in the circuit, that is transformed by the L1 L2 coil to L3 coil. That time the potential difference produced across the plates. So at the same time the frequency will be calculated. That time what is the frequency of this oscillator circuit is means F is equal to 1 by 2 pi square root of L1 C1. Okay, then next condition is we have to adjust the value of the capacitor. Okay, initially the capacitor have some value, that time frequency is here. Next time we have to adjust the value of the capacitor from minimum to maximum. So, the frequency also changed according to the value of the capacitor. Then same process going like this, current is produced in the circuit and also transformed to the next circuit, and the potential difference is produced across the plates. Okay. Then what is the resonant condition means? We have continuously adjust the value of the capacitor, the frequency is produced, we have to calculate the frequency value according to the value of the capacitor. What is a resonant condition means? At which point or which condition the oscillator frequency, this f is equal to 1 by 2 pi square root of LC, this value, this frequency value of this capacitor, this frequency value of this oscillator coincide or equal to frequency of the crystal vibration or quartz crystal. When crystal vibration started, we have to produce current in the primary circuit by switch on the battery, by adjusting the variable capacitor, the current is transformed to the next circuit, potential difference is produced at the two ends of the plates. That time the crystal vibration started. Okay. So, crystal vibration started, we have to adjust the value of the capacitor, the frequency of the oscillator circuits also varied. So, we have to calculate the value of F depend on the value of C. Okay. So, at resonance means already the crystal vibration started going like this based on the capacitor value or based on the frequency of this oscillator circuit, at which time the frequency of the oscillator circuit equal to the natural frequency of the crystal vibration. You already know quartz crystal is connected inside these plates, at which point the frequency of the oscillator circuit equal to the natural frequency of the crystal or crystal vibration. That time only the resonance occur. That time only the resonance means that time only the ultrasonic waves produced by the quartz crystal at the end of the quartz crystal. Okay. So, at the resonance condition only the quartz crystal producing the ultrasonic waves. So, the main point or main thing in this oscillator circuit is there is a resonance point. The resonant point is at which point or which time this frequency of the oscillator circuit exactly coincide or exactly equal to the natural frequency of the crystal vibration. That time only the quartz crystal producing ultrasonic waves. Okay. So, this is the main thing in the oscillator circuit. So, after producing the ultrasonic waves using this quartz crystal, we have to get a maximum of 500 megahertz of ultrasonic waves can be produced by this ultrasonic oscillator. Okay. This is the main advantage of this oscillator, maximum of 500 megahertz of ultrasonic waves produced by this oscillator. Okay. What is the main disadvantage or what is the quite difficulty of this quartz crystal used in this piezoelectric oscillator means the cost of the quartz crystal is very high. It is one main point. And another point is the cutting of the quartz crystal. So, before starting this oscillator topic, we already saw what is X cut and Y cut of the crystal. Okay. The cutting of the X cut and Y cut of the quartz crystal is quite difficult. It is one of the main disadvantage of using quartz crystal in this oscillator. Okay. Then remaining points are all our advantages. We have to produce 500 megahertz and also it is not temperature dependent or humidity dependent. So, we have to produce ultrasonic waves at any temperature or any humidity. So, that is one another important of the piezoelectric oscillator. So, in this oscillator we have to produce the ultrasonic waves. Ultrasonic waves having many application, then only we have to produce the ultrasonic waves by this oscillator. The main thing of this oscillator is the transistor working and transformer function and the quartz crystal function. The quartz crystal before starting this oscillator function we have to fix the quartz crystal based on their cutting X cut Y cut. Suppose we want to produce some transverse mode of ultrasonic waves means we have to fix X-cut quartz crystal, okay, sorry, Y-cut quartz crystal. In the case of transverse, we want some transverse wave of ultrasonic waves means we have to use the Y-cut crystal, okay. So, based on that cutting only we have to fix the quartz crystal inside the parallel plate of the piezoelectric oscillator, parallel plates of the piezoelectric oscillator. At the resonant condition, we have to produce some mode of ultrasonic waves, okay, maximum of 500 megahertz. So, this is the basic about this piezoelectric oscillator and the construction and what is the resonance point and what is the advantage, okay. So, what is the main learning objective of this topic means how we can produce this ultrasonic waves by this piezoelectric oscillator. So, at the end of the session, I hope you are all very known about what is the piezoelectric base, what is the main principle of this piezoelectric oscillator, that is inverse piezoelectric effect. Based on the principle only this piezoelectric oscillator works, okay. And what is in the piezoelectric oscillator circuit, the main thing is resonance. So, the resonant point is at which point the frequency of the oscillator circuit exactly coincide with the natural frequency of the quartz crystal. That time only the quartz crystal producing some ultrasonic waves, okay. So, these are the main thing. So, this is the learning objective of this topic. Thank you.